and Cartesian, which is normal. We shall try. Okay, any idea how you do this?
You could do like t is equal to x over 2,
Mm-hmm.
and then you can substitute x over 2 like in the y equation. So it's like y equals x over 2 squared.
Yep, that's it.
And then that equals x squared over 4.
Okay, B.
Well, the range would just be, wouldn't the range just be -3? Wait, no, maybe not. The domain would be -3t3. Or would that be the range? I'm not sure which one it would be.
F of x. We just found y equals f of x. So for the Cartesian one.
It's different. Okay. How do you know what the domain and range of that is?
So I believe x can be any real number.
Mm-hmm.
And is y the same?
Yeah.
Y can be anything. Let me think. No. If you were to graph that, what would it look like?
Oh, is it y has to be greater than 0 or equal?
Yes, y is greater than or equal to 0 because -1 squared is +1.
Yeah.
0 squared is 0, so it kind of bounces back. And C, sketch the curve. How would you do that?
When you have to like figure out the coordinates and then kind of. So at -3, it's -6, 9.
How did you get -9?
No, -6 and then 9. Like the x coordinate.
Yes.
-6.
-6, 9. Okay.
And then it's 6, 9. Yeah, so you just figure it out for like each of them.
Yeah, 6, 9. And you would have to put in, let's say, the integer values. So -3, -2, -1, 0, 1, 2, 3. Yeah. What would be when it's 0?
0, 0.
So it might look something like that.
Yeah.
Do you know what the significance is of less than and not less than or equal to? How you can show that?
No.
If it was, well, it should be, I believe, unfilled circles.
Like I thought that was, I didn't know you could do that for graphs. I thought that was only for inequalities.
It looks like an inequality to me.
I mean, like when you show it on the number line, like I didn't know you could do that for graphs as well.
Yeah. So that GCSE malarkey that we were doing, yeah, it can be here. Let's see if they want it. No, they didn't bother, but they should. Oops. Let's see. So yeah, that's what it is. You plot the points and do it that way. Y equals x squared over 4. Great.
Mm-hmm.
The domain. No, we're wrong. We're wrong. So basically, the domain
is -6 to 6.
Yeah, x is between 6 and.
And then for part, like for the y one, the range, it would just be 0 to 9.
Yep, looks like it. So let's see. So that's between 0 and 9, and it's or equal to, I believe, because it can.
Yeah.
No, actually, it can't be, can it?
Yeah, it can, because 3 squared is 9.
But t can't be 3.
Oh, yeah.
So I think that's what it'll be for all of them.
Yeah. Oh, it's 0. It is equal to for some reason.
Ah, yes, because when it is minus.
When it's 0, it's
going
to be 0. So yeah.
When it is 0, because it because t can be 0. There you go.
Yeah.
Okay, so this is the constraint that constrains the x and the y. All right. Any questions there?
Not really.
Okay, so I thought it was separate, just this y equals f of x thing. Oh, it's getting tricky. How about this?
So you've got to rearrange one of them.
Which one will we
I
rearrange?
don't know which one's easier to rearrange. Probably the y one is easier.
Yeah. Hold on. Before we do that, it wants us to put it in the form of y equals.
Oh,
And
never
this one is
mind.
already y equals, so it might be
Yeah,
easier.
I have to change you have to rearrange the x one then.
Yeah.
So it'd be e to the x minus 3 is equal to t.
Yeah.
So then y is equal to 1 over e to the x minus 3 plus 5. So y is equal to e to the x plus 2. Yeah.
Looks good to me. And b.
Does it mean x is greater than k? Where k is a constant to be found.
Find a Cartesian equation of the curve of the form and x is greater than k. Y equals where k is a constant to be found. So that's the domain. Well, let's use this. T is greater than minus 2.
Mm-hmm.
How can you use that?
You can solve for x.
How?
By putting t is minus 2
Into where?
into like e to the x minus 3 equals t.
Okay. That would give you y.
Oh, okay. I don't know then.
Into the x one.
Oh, okay. Oh yeah, because you need to find x. Okay. So you just do ln minus 2 plus 3.
Mm-hmm. Ln minus 2 plus 3.
So x is ln 1, which is 0. So x is greater than 0.
X is greater than 0. K. B.
Range. Okay, that's y. I think it's y is greater than minus 1/3. Wait, no, that's wrong. Because then it's minus 1. Oh wait, it's just 1/4. The smallest it can be. Oh, I think it's y is less than 1/4, less than or equal to.
How do you get that?
Because when you substitute like t is minus 1, then
Can t
you
be
get
can t be minus 1.9?
yeah. Yeah, that's why it's greater than. Oh.
So you'd
Okay.
same as
It's just 1/3, but not equal to. Y is less than 1/3.
well done.
Equal.
Yes. So you did the difficult bit and you stumbled on the easy bit. So the difficult bit is knowing that it will be less than because as t increases, y decreases because it's on there. Yep. I hope that's it. There we go. Y is between 0 and 1/3. So y, yes, because with a fraction, yeah, this would include negative numbers. So actually we should have said it's between 0 and 1/3.
Yeah, because it's always positive.
There we go. And it will get close to 0 but never touch it. never actually be 0. So it's not or equal to. And the x is greater than 0. That's all right. Oops. Any questions there?
No.
Okay.
I don't really know how to find like domain and range. Like even in functions questions, I find it really hard.
You
Like
just
I
did
don't know.
it. You just did it twice.
Yeah,
So
but I don't know how to do it for like functions. Like functions, a topic.
it would be something like, so imagine if it was y is
Like
equal to,
usually I just like graph it on my calculator and then try and figure it out. But is there like another way?
no, that's it. That's the best way
Okay.
of doing it. So you have some
Okay.
function and it looks like that, and you can say, yeah, x has to be greater than 0, y has to be greater than 0, whatever it might be.
Okay.
Your method is a good one. But with those function things, the same stuff comes up over and over again, which is the denominator can't be 0. And so you just do cancel that.
Yeah.
Let's see. This one, I think this is okay. Domain and range. We can do domain and range if you want.
Yeah. And state the domain range. Oh, you have to find what fx is first. So,
You don't have to, but okay.
I'm going to. X is equal to t over 3.
No. X is equal to 3t. Do you mean t equals?
T is equal to x over 3.
Uh-huh.
So y is equal to 1 minus x over 3 and 9 minus x over 3. Do you have to expand it or can you just leave it like that?
Did they tell you have to expand it?
No.
Good enough for me. And as far as I'm concerned, that's 1 mark. The domain will be 1 mark and the range will be 1 mark.
Yeah.
And it's 3 marks.
Yeah, I don't know how to find it, so I'm going to try and graph it and see if it works, but I don't know if it will.
It won't, because this is parametric.
Oh, it won't like be on a graph.
It'll be misleading. You might get the right answer accidentally.
Okay, I have no clue what it's showing, so it can just be anything.
Exactly.
Wait, no.
So that's the mistake we made on the very first one. We thought x could be any real number. Why could it not be?
Because it's restricted. Oh, that one is as well on that question. It said like 0 to 8.
Yep.
Something.
0 to 8.
Okay. So that means that the domain is like 0 to 24.
Mm-hmm.
And they're both equal to, yeah, like that. And then y is, would it be between 1 and 9? Y? Or is that not right?
I don't know. So one of them, when you put in 0, you'll get 9.
Yeah. And the other one will be 1.
And then when you put in 8, 9 minus 8 is 1, times by 1 minus 8.
That's minus 7.
Mm-hmm.
Okay, it can't be 1 to 8 then.
So what is it?
Less than equal to 9.
Is minus 10 less than or equal to 9?
Minus 10.
Minus 10 is less than 9, isn't it?
Yeah, of course.
Okay, can y be minus 10?
Can it be? I don't know if it could be. Yeah. It can be, I guess.
It could be, except these is what they gave us. So what value of t is going to give us minus 10? It's going to be outside of t's domain.
Yeah. Oh, so you need to put like a lower thing on 9.
So what is our lower one?
-7?
Yeah. So it
Okay.
would have been anything less than that, but actually they constrained it, and so we have to constrain it as well.
Okay.
That's a little trick to watch for. Hopefully we're correct. And if we
Isn't
graph,
that hard? You just like, I don't really know how to explain it, but you just like use the equation.
yeah,
-16. How?
we're wrong.
Yeah, something happened.
It's because we didn't graph it. We could do table of values.
How can it be 15 though?
That's the minimum. So when you put in, when x is 15.
But then how is it included in the range? Because it's not 0 to 8 clearly.
I think it is. There is some value of t that when you put it in,
Okay.
you get.
It's going to be x is 15 and t is 5.
When x is 15, t is 5. Aha, there we go. So we need to actually sketch these things.
That's what I did.
Did you get a minimum of 15 minus 16?
Wait, are you meant to put in like x is equal to 3t? And then y, like, do you have to put them in separately?
You can do it parametrically, yeah.
I don't know how to do that, so I'm just going to put in the like rearranged version.
Cartesian, yeah, that'll work too.
What's the balances? Not found. There's no minimum, apparently.
It might be a local minimum between like 0 and 8 in terms of t, or between 0 and 24 in terms of x.
I'll try and find it. There's a root at x equals 3.
Nope.
No? That doesn't mean anything.
Well, we're not concerned with roots. We just need to minor range. 1 minus x. What does this thing do? There we go. Okay, y equals 1 minus x, where is fraction, over 3, close bracket, open bracket, 9 minus x.
When I put x equals 15, it said argument error. So, I'm not sure what that means.
We draw this. Okay. Shift graphical solve.
How do you get that?
Shift F5, graphical solve.
No, I know. I mean, like, it's so zoomed out. I don't know how to do that.
You can change the zoom. Shift zoom, shift view window.
Yeah, but I can never see, like, the whole thing.
It's gonna go on forever. So here's a different view, if you prefer. Shift graphical solve.
It's like weird. Like, I can't tell it's quadratic.
Shift F2 for zoom, and choose maybe auto F5.
I did put auto, but it didn't work.
You cheek this man. Shift view window. I don't know. Box maybe. Oh no.
That would be child different settings. Box is weird.
You select it yourself with box. I just like the kind of automatic thing, whatever it might be. Try this one.
Okay, now I can tell it's a quadratic because I just moved. Press the arrow key.
So we need to find the minimum. You could also do a table of values. How do we do a table in this thing? 7. So if we do a table of values with this thing, table, but I need to set F5. So we're going to start x is 0 and end x is 28, steps of 1. And we just look for the minimum y. Oh, I've got y and y dash. Oh, wow. Yeah, so it goes down to minus 16 when x is 15. That can be a simpler check if graph is
I did it.
You got the graph
Yay.
going? Great.
Yeah.
Any
I
questions
just
there?
press Alt and Enter.
Ooh, what did I press? I don't know what I did. Okay. Any questions there?
No.
Okay. Let us try.
Yeah. I just didn't get why it was minus 16, but because it didn't work on my calculator.
Okay, let's try this.
Oh, but now it's showing a minimum. Okay.
Yeah,
That's why.
graphical solve is the easiest way, I think.
Find the Cartesian equation. And then just find the minimum. Okay. So x is equal. Okay. So e to the x minus 5 is equal to t. So then y is equal. Y is equal to 2e to the x plus 2.
Sorry, e to the x was equal to what, sorry?
E to the x minus 5 is equal to t.
Aha, yeah. Okay, and part B.
Y is equal to 2e to the x plus 2. Oh, plus 1 if you put it in brackets, but plus 12.
Sure. Part B.
Part B. Oh, the minimum. Okay. Graph time. Oh, wait, why did I? Okay. I have no idea, but.
Why would you have no idea?
Because it says minimum not found. Oh, I see why. There's like an asymptote, like a weird one.
Yep.
1 sec. I think it's at 2. Like y equals 2 is the asymptote.
So y is equal to 2. Okay.
And the minimum value of x, I'm pretty sure it goes on forever. Oh wait, no, it doesn't. There's another asymptote.
Have you learned nothing? Very first question we did, Amogha. We said x is an element of the real numbers. But it wasn't. Why?
But it's not. Oh, because the range is restricted.
T is greater than or equal to minus 4.
I don't know what that means. Oh, it's just ln 1. See, x is greater than, no, x equals 0.
Yep. And so
how can, but the minimum value of x isn't 0. Because x equals 5 exists. So, oh, but not in this range. Okay, I understand this now.
So x0 what? Less than, greater than, equal to what?
I think it's just equal because this is right down the minimum.
Oh, it's the minimum. Yeah, so x is equal to 0. And when x is 0, what is y? Is it 2?
No. No, it's 4.
So at the minimum is 0, 4?
I don't think that's right, but no, it's not. I don't think it means together. I think it means like separately. Like, I don't think it's a coordinate. Like, I don't think it's 1 point, like a minimum point. It's just like the minimum value. It's 2 marks as well, so it can't be like a coordinate.
So y is 4 and x is 0?
I'm not sure if it's 4, but yeah.
So when t is -4,
Oh yeah, it's 4.
and it'll only get
This
bigger.
is really easy. You don't even need to like graph it.
Well, the quadratic ones we did need to graph it.
Okay, but this one you don't.
Yeah. Any questions there?
Not really. Once I get it, it's
So this quadratic one, we thought it goes from 9 to -7, but it actually went lower in between those two. So we just have to watch out for
I
that.
just don't get domain and range in general, so
All right.
it's not this topic problem.
Looks like we're doing it again.
Examine the ranges x and y. T is not equal to 0. Wait, does real numbers include negative or not?
Does real numbers include negatives? Yes.
It does. Okay. So I can literally anything. Then. Yay! I have no idea how to do this. I know the second part, but
Hold on. Hold on.
it can be anything except 0. So how are you meant to determine the range?
So what is the domain for x?
I don't know.
So you're
X
saying
not equal to 2?
x is not equal to 2.
Yeah.
And x is an element of the real numbers?
Yeah, I think so.
So similar to that one. Okay, how about y?
Y is not equal to -3. But everything else is okay. Y.
You don't know that. Graph this and just use x instead of t for the sake of simplicity.
So it's just weird for quadratics, basically. Like, quadratics are the only ones you need to graph. Why is it showing like this? Oh, G solve max. Y is less than or equal to -2.
Y is less than or equal to -2. Is that because that's the maximum?
Yeah.
Okay. Let me check. So this one, y when t blah blah blah. Let me just move it across. A second.
For x, you don't need to write its part of all real numbers. It says x is just.
I think you do, but they're just being forgiving. X is not equal to 2, and then y is a bunch of blah blah. Y is less than or equal to -2, and y is not equal to -3. Correct. Part B, show that it can be written that way. I think that's fine. Just rearrange sub integral. Any questions there?
No.
Okay.
I'm sort of getting the domain range bits.
So quadratics, just watch out for it. So the x part was okay. What's this malarkey? And then the curve has this parametric.
There's no domain and range, so.
There's no domain and range. Oh, do you mean they didn't ask us, was it?
Yeah.
Show
Like,
it can be
it's
written
not a question.
in this form. Okay, how would you go about this one?
The same way you do all the other ones.
Okay.
Rearrange to find t. So ln x is equal to 3t. So t is equal to ln x over 3.
And I'm going to write that as a third ln x.
Yeah. And then, so y is equal to e to 1/3 ln x somehow.
9 times
9 times, yeah.
ln x.
Which I'm guessing would just go to 3x, but I'm not sure if that's right.
I believe so. That would be 3x, and so on.
Yeah.
Hang on. 3x, or is it x cubed? Ln 3.
Why would it be 3x? I mean, why would it be x cubed? I don't understand.
E to the ln x is just.
Oh, because it's 3 ln x, and then in log rules, when it's like in front of it, it goes to the power. That makes sense.
Yes.
I forgot about that.
So,
But it's a thing.
okay, what else?
And then 2e to 6 times.
Yes, it has to be e to the ln. It can't have be e to the
I think that would
something
be
ln.
2x squared minus 2x squared.
Okay.
I think. And then that would be minus 5x plus 6.
Okay. Minus 2x squared minus 5x plus 6.
And then calculator.
And
We'll
then
solve.
calculator to factorize it. And then calculator for b. Yeah, great. Any questions there?
No.
So, yeah, e to the... It can't be e to the something ln. It has to be
Yeah.
e to the ln, and then it will simplify. Okay, stuff's about to get real.
Show that goes. I don't know how to do. Oh wait, I do. Never mind. But how do you do dy by dx for these? Or do you not need to? I don't know how to show they're perpendicular to each other.
What do you know about perpendicular gradients?
Negative reciprocal of each other.
And there's a way to prove it. Do you know how to prove it?
No, you literally just find the gradient.
Nope. You multiply them. What do you get?
Oh, -1.
And that's how you prove it. So you're correct that they are negative reciprocal, but prove it, they multiply to make -1.
Mm-hmm.
Even though it's obvious that 9 is the negative reciprocal of -1/9.
So how do you find the gradient of those? Oh, you have to make them like Cartesian equations.
Hang on a second.
Differentiate them?
So you really want to differentiate, don't you?
I don't know how else to find gradients. Oh wait, you just do change in y over change in x, can't you?
Yeah.
Oh, okay. So for the first one, that would be 12 minus 0.
Hang on.
20.
Hang on. Show that the curves are line segments. That doesn't make any sense. What do you mean the curve is a line?
Yeah, how can a curve be a line segment?
So maybe if... So show that the curves are line segments. I don't know how you show that they are line segments. Let's see.
How can... You don't need to, I don't think.
Hang on. So
Yeah.
x is that. Y is that. Y is equal to...
They made it into a Cartesian thing.
So they just made
They
t
just made
t squared the subject. Okay. So
yeah, I feel like that's a long way to do it. You don't need to do it.
okay.
I think change in y over change in x is just so much easier.
It's not that. If they just said the second part, then you could say yes. But if you have to show that they are lines.
But how does rearranging into Cartesian equation show that they're line segments?
Because it will just be...
Because it's y equals mx plus c.
Yeah.
Okay. That's fine.
5/5
That's confusing. Don't like it.
So how about second one then?
x is equal to 3 root t minus 3. So x plus 3 over 3, the whole squared, is equal to t.
Nope. Just leave it as equals root t.
X plus 3 over 3 is equal to root t.
Mm-hmm.
So that's it.
So y equals?
Oh, because that has root t in it. So y equals 9 minus 5 x plus 3 over 3.
Yeah. And perpendicular.
Wouldn't you just like expand it? So 5x plus 15 over 3.
So I think one is y is equal to 3 over 5x plus 2, and the other is y is equal to minus 5 over 3x plus 4.
That is correct. They are negative. And then you have to multiply them and show that it's equal to minus 1.
Yeah, m1 equals 3 over 5, m2 equals minus 5 over 3, 3 over 5 times minus 5 over 3 is equal to minus 1, therefore perpendicular. And then what is this malarkey?
Oh no.
Find the exact length of each line segment. Yes, you do.
Oh no. This is like that really complicated formula where it's like square root of y2 minus y1 squared plus. Is that one right?
That one arguably from GCSE, that really complicated formula.
Yeah.
You do much more complicated stuff than that.
I don't like that. I don't like that formula. It took me so long to remember it. So yeah, you just do that basically.
Okay, yeah, I think you'd be fine. And that really complicated one that you're talking about is you would just find the coordinates of each end point.
Yeah.
And then it's just
do
Pythagoras
that.
from that.
Pythagoras.
Yep. That's all that thing is.
Oh, that is the complicated formula. Okay.
Yeah. Let me see this. Find dy dt. That might be easy. Yep. Find a Cartesian. That's okay. Hold on. No, it isn't. Right, we have to do this one.
It's not okay. That's not looking good for me. So x over 3 is equal to root t. So then x squared over 9 is equal to t.
Yeah.
And then y is equal to x squared over 9 cubed minus 2 times x squared over 9.
Hold on. This has t cubed.
Yeah, you just cube it.
Okay.
You get y is equal to x to the power of 6 over 9. Wait, no, not over 9. Over 9 cubed. Which is 729. Can I just leave it like that?
Yeah. So x to the 6 over 729, is it?
Yeah, but do you have to write that bit? Or?
You don't have to expand it. They didn't say you had to, but okay.
Yeah, that basically.
And yeah.
Would it be wrong if you wrote it as like 2 over 9 x squared, or like no, it wouldn't be.
Same thing. And I think you get full marks at this point.
Okay. It's only 3 marks anyway. 1 mark is for the domain, so state the domain of fx. 0 to 3 root 2 is the domain.
0, 3.
No, fx. Oh wait, yeah, that's just x.
Yeah, domain is x. Range is y.
Show that dy over dt equals 0 and t is equal to Okay, so you just need to differentiate the y equation. So dy by dt is equal to 3t squared minus 2. And then you just solve like equal to 0. So 3t squared is equal to 2. T squared is equal to 2/3. And then, yeah, t is equal to 2/3. Hence, determine the range. Why do you need that to find the range?
What do you know about a curve when the dy by dx is 0?
The minimum point.
So that's the minimum. So the minimum
So
value.
it has to be greater than root 2/3. Y has to be greater than that.
So at the minimum, t is
Oh,
root 2/3.
but y is not root 2/3. So that would just be root 2/3 cubed minus 2 times root 2/3 minus root 6/3.
Minus root 6/3. Is that the... So what's the range?
Y is greater than or equal to.
Or equal to that. And that was when we subbed in root 2/3. Root 2/3 cubed minus 2 times root 2/3. Teeny tiny. And hence determine range. Let's see how we did. So I have our x thing down there. Between 0 x is, yeah.
Yay.
This one was fine. And then
Oh no. Apparently it's only till 4. Oh, we forgot the upper end.
We forgot the upper end. So this is...
Yeah.
Yeah.
So it's 4.
4 root 6/9 though.
Is that not what we did? Oh. Okay. I don't know.
They just got a different answer. Let's see. So they subbed it in.
How did they get a different answer if I did it in my calculator? Oh, they did squared, I think, instead of cubed.
They
No,
did cubed.
I'll try again, but... Okay. Oh, now I got minus 4 root 6/9. Okay, the square root 2/3 confused the calculator.
Okay, so y is in between 4 and that, is it?
Mm-hmm.
4 root 6/9. Yeah, okay. Any questions there?
No, not really.
Yeah, we just have to remember to put in the upper thing as well. Let's see this one. Find a Cartesian one. This is just okay, we have to do one of these.
Why? Okay, t squared is equal to x/4. But you could just make it into t is equal to root x/2.
Okay.
That means y is equal to 8 root x/2. Is x to the power of 3/2.
Your audio's gone a bit.
Huh? Oh. Actually, yeah, I can hear like a noise, but I don't know where it's coming from.
That's all right. It's better than it was. So this is what you did, is it?
The X's, no, the 8's cancel out. Wait, where did the -1 come from?
Oh, sorry, that's not part of it. Is
Yeah,
this it?
you get 8x to the power 3/2 over 8. So the 8's just cancel out.
Sure. So what is the
So
answer?
it's just y is equal to x to the power 3/2. But it wants y squared. So if you square that, I don't know what you would get. 3, you just get x cubed. Y squared equals x cubed.
Y squared equals x cubed. This might be wrong. Might be right. So the way you would do it is, so they wanted y squared in the beginning.
Yeah.
What is y squared in the beginning?
64t to the power 6.
T to the 6. So how could you get t to the 6 for this one?
Times by t to the 4.
Cube both sides.
Otherwise
you'll have t on the other side as well.
Yeah.
So x cubed is equal to, is it 64t to the 6? They're both equal to the same thing. Yep, worked out. There you go. Did work. Yes, it's just because if you graph y equals, you only get half of it. You have to graph y squared equals. All right, worked out. There you go.
But does it always work in both methods, or are there some where it doesn't work in the way I did it and it does in the way you did it?
I think if they had said find a Cartesian equation of C, and you had said y equals this, like y equals root x cubed, I think that would be wrong, because if you graph that, you would get half of the graph, because you don't get the negative numbers, because they can't be you can't have a negative square root. Yeah. Whereas when you graph,
so it's better to use that method.
Yeah, it's like lowest common multiple. Lowest common multiple of 2 and 3.
It's not that complicated, so.
Yeah.
But how do you know when you're meant to square it? Is it just when you have a square root?
It's when you have one is a square root and the other isn't, because square root gets rid of those values. Let's see this one.
Like this one, would you have to do that?
Okay, yeah, I did do that. Oof. It's not easy.
So x squared. So you square the x1, which should be x squared is equal to t over 9 minus t squared.
T over 9?
No, t to the power of 9. Wait, no, 6. Not 9. What am I saying?
Hold on. You've got a whole thing ahead of you here. You'd have to do t cubed minus t squared, yeah?
Can you not square them I didn't know you couldn't do it separately. But that makes sense.
Yeah, you're going to have two things in the middle as well, which might simplify down to one thing.
Oh, I know how to do that. It's just x squared is equal to a squared. So x squared is equal to t to the 6 minus 2t to the 4 plus t squared.
Plus t squared, okay.
Okay, and then y. What do you have to do again to make them equal?
Hold on, show that this can be written in this form. So then we have to sub it in. Let's see.
Wouldn't you have to sub the y one into the x one and then just square?
Yeah, Uh,
Wouldn't that be easier?
Hold on.
Like you just do x is like you just rearrange the y one to find t.
So do you mean t would be the square root
Oh
or
wait, no,
something?
that's complicated. Never mind.
What
I
would
don't understand this question.
t squared be equal to?
T squared. 4 minus y.
4 minus y. And so, what can you do with that?
Square root.
Nope. So let's say
It,
here.
substitute. There we
Yeah.
go. So x squared is equal to 4 minus y cubed
Very good.
minus 2 4 minus y squared
Squared
plus 4
plus
minus y.
4 minus y.
Solve that.
And then you just fully expand and fully factorize.
And then, how is that only 3 marks? That's such a long question.
Let's see.
There's gotta be an easier way to do this.
They factorized it.
Oh, that's nice.
T squared minus 1. So t squared. So they
That's
factorized.
way easier.
Yeah, they're smarter. They're smarter than I am. And then you just find minimum, maximum.
Maximum.
Is that one okay?
Yeah.
Okay. And so parametric equations.
Maybe like half, I think.
Let's see. Oh, come on.
I don't really get these like square cube ones.
So parametrics, like big picture, is when you put it together, you get this weird equation, and so it can be helpful. Yeah. It can be helpful to define them separately. So x is doubling each time, and y is squaring each time. So when you put them together, it's weird, but when you have them separate, it can help. Domain and range, yes. Sub in your t. You might have to sketch, and they tend to get you to sketch it if you need to sketch it. Okay. So yes. So this one, what's the range for this one?
The range, just greater than y is greater than equal to 0.
No. You're half right. It has to be
9.
Yes.
Okay.
Yeah, so it has to be greater than or equal to 0, but less than 9. And so we just have to remember it's got 2 ends to it. Same with the x, minus 6 to plus 6.
But it doesn't always have 2 ends, though.
Doesn't always. Yep. So you just have to check the t. What t is constrained to. Let's see. So this is pretty okay. Yeah, the e to the stuff you're pretty good for. Yeah, that was same thing. Just make sure you get both ends. So this was the type where you have to sketch it, and so part B makes us sketch it. And so if you have to sketch it, then you'll probably notice that the domain and range. So if you were to sketch this out, yeah, x is between 0 and 24, y is between minus 16 and 9. We thought it was between minus 7 and 9, but that's because we didn't sketch it. It has a lower minimum than the 2 endpoints. The 2 endpoints aren't necessarily one of the lowest points. Let's see. This one was similar. So this one has quite a common one where you can't have 0 as a denominator, and so other than that, that was fine. This one, yes. Why was it not 3x? Why was it x cubed?
Log rules.
Yeah, you have to bring the 3 to the front. So e to the something ln can't simplify. E to the ln something can. Just watch out for that. This one, this was easy-ish because this one is t squared and this one is t squared. This one is root t and this one is root t. So make t squared the subject for each, make them equal to each other. Make root t the subject of each, make them equal to each other. So we didn't have to monkey around with any stuff there. and then exact length of the line segment is basically Pythagoras. That complicated thing you said was it's basically Pythagoras. This one, they used differentiation to find the minimum. That's one way. You can graphical solve calculator to find the minimum, whichever way you want. And once again, we just have to remember the top part as well. So we said it's greater than the minimum, but we have to also say it's less than this maximum in terms of t. This one, lowest common multiple, 2 and 3 is 6. That's why we ended up with getting them 6. They said y squared equals. Sometimes they might not say that, and so we might just assume it's y equals. But if you do the y equals, you've only got half of your graph. You won't have the negative half, and so you have to you go upwards as opposed to downwards. We're used to always going downwards to like t to the 1, like square root. In this case, you have to go upwards. They used a fancy method, so they factorized this one, so that one was t squared, and then the other one was t squared, so it worked out quite well. But I didn't know that in the beginning, so we just expanded the brackets. We went upwards again, and it worked. They just did the same thing, but a quicker way. It's kind of contrived. Well, I don't like the look of squaring this thing. So the square of that is t squared, and t squared minus 1 squared. That scares me a little bit. I prefer our way, if you prefer that way.
Yeah, it's easier.
How is that for you, Amogha?
Okay, a bit hard, but not like that bad.
So there's a whole lot more parametrics.
I'm trying to do it.
You want to continue parametrics next time?
Yeah.
Okay. Any questions for me in general?
My mom was wondering how much to pay for the lesson on Wednesday.
Oh yeah, just half the normal amount.
Okay, thank you.
All right. Anything else?
Nope.
All right. Well done, Amogha. You did great, and I look forward to seeing you again next week.
Bye.
Have a good week. Goodbye.